Hello everyone, here is a question based on ionic compounds. The orange color of potassium dichromate and purple color of potassium permanganate is due to what type of transition? First of all, let us determine the oxidation state of the central metal ion in both the cases to see whether d electrons are there or not. For potassium, we give plus 1 as the charge. We have 2 potassium atoms, so therefore plus 2 here. For chromium, we are going to determine it, therefore plus 2x because we have 2 chromium atoms, plus 7 times minus 2 because that's what the charge we give for oxygen, and that is equal to 0. So therefore 2x minus 12 equal to 0. Therefore x is equal to plus 6. This means chromium is in plus 6 oxidation state. We know that the atomic number of chromium is 24. So when it is neutral, the electronic configuration is argon, that has 18 electrons, and then 4s1 3d5, not 4s2 3d4, because half filled and completely filled d orbitals are more stable due to exchange energy, and that's why we write the electronic configuration like this. Now when chromium is in plus 6 oxidation state, how many electrons we will have? We will have only 18 electrons, isn't it? So all the electrons that are there in d orbitals and 1 electron that is there in the 4s orbital should be removed. So this means the electronic configuration is simply argon, which means no d electron, which means no dd transition. So therefore option 4 is wrong. Option 3 is also wrong. Now let's come to potassium permanganate. Plus 1 plus x minus 8 equal to 0. So therefore x minus 7 is equal to 0. Therefore x is equal to plus 7. Manganese is in plus 7 oxidation state. Manganese atomic number is 25. When it is neutral, the electronic configuration is argon and then 4s2 3d5. Total 25 electrons. But when it is in plus 7 oxidation state, we have only 18 electrons. This means all these electrons should be removed. Therefore the electronic configuration is once again equal to simply argon. This means no d electron, therefore no dd transition. At least one d electron should be there. dd transition is not possible for d equal to 0 as well as d equal to 10, which you can come across for zinc 2 plus. In these two cases, dd transition is no. So therefore option 1 is correct. Charge transfer transition in both. Electrons are momentarily transferred from the oxygen, that is O2 minus ligands, to the empty d orbitals of the central metal ion. That's how these ionic compounds get their color, which is normally referred as ligand to metal charge transfer. That's how these ionic compounds get their color.